Hello, my name is Bailey. This is my partner Ulrad. This is our project.
Yes, our project name is Plant Feeding Organic Insecticides from Acroptilon and Fish Based Against Root-Eating Insects. Plants are the most important product of the life because they are vital as nutrient and environmentally. But they are damaged by root-eating worms and insects while they are seedlings. Nowadays, synthetic agents are used against pests and insects. Synthetic insecticides have some disadvantages such as toxicity to humans, water pollution, soil contamination. So it's necessary to use biological agents to control damaging organisms. In general, traditional plants are a valuable source of novel product. Acroptilon repens have reactive structure to repel insects as an alternative to synthetic pesticides. This study was designed to investigate the usage of Acroptilon repens and fish waste against insects. Acroptilon repens is a natural plant which extensively grows in Turkmenistan. This plant has medical uses but generally known as a weed. And fish waste contain high organic contents that are fertilizer for plants. Fish eat insects for nutrition. That's why insects run away from fish. Fish smell, and we want to use fish waste as a fertilizer and to keep plants damaging insects away. The main purpose project is to make insect repellent insecticides from Acroptilon repens and fish waste. We did some experiments to test antibacterial and antifungal activities of Acroptilon repens. Then we made insecticides from Russian knapweed and fish waste and tested repellent activity. We did 2 experiments to study Acroptilon repens and fish waste. First experiment is to study Acroptilon repens in 3 steps. Step 1. Hydro distillation of knapweed. Acroptilon repens was collected from a schoolyard. Stems and leaves were separated in shade conditions. The powder was subjected to distillation process in order to obtain water extract of knapweed. 100 gram sample extract with 200 gram water for 3 hours at 80 degrees Celsius. Prepared extract was kept in closed container and for tests. Use 2 pieces of bread to control antifungal property of Acroptilon repens. Because bread is one of the culture medium of some fungi. First bread was for control. Second bread is spread extract of knapweed. The breads were packaged and incubated at 30 degrees Celsius for a week. A week later, reproduction of fungi on the second petri dish was observed with reference of the first petri dish. Step 3. Determination of antifungal properties of knapweed extract. We use 2 pieces of bread to control antifungal activity of Acroptilon repens. Because bread is one of the culture medium of some fungi. First piece was for control, and second piece of bread was sprayed with knapweed extract. The breads were packaged and incubated at 30 degrees Celsius for a week. A week later, reproduction of fungi on the second bread was observed with the reference of first bread.
Second experiment is done. Study fish waste. We cut fish waste into small pieces, dried and powdered them. The powder and the knapweed extract were blended with the soil homogeneously. Then we prepared a special container that is divided in 3+1 parts. A fish waste powder and this soil knapweed extract with soil, normal soil, and filled the container. My mole crickets type of the road feed insects. When put on the soil and container, the observation gives us the repellent activity of the fish waste powder and knapweed extract. After that open sowing period, we carried on the experiment in tomato hothouse in Aklaşehir, Bukhara. Fish waste powder and extract were missing. The mixture was scattered to the land before each irrigant unit. The fiddle developed at the harvest time to compost the collection of tomato crop with the last year harvest.
As a result, experiments provide an overview to insect repellents of properties of Acroptilon repens and fish waste. Acroptilon repens and fish waste has strong repellent potential against root feeders. When the insecticide is used, damage of the tomato seedlings has significant decrease from 74 to 7, and crop yield increased by 38.2%.
As conclusion, the result obtained in this study clearly shows that Acroptilon repens and fish waste further has strong repellent potential organic insecticides should be made by them against root